Okay, so let's talk about some things here. Okay? You all had an inequality to graph, and then you combined two of them. So let's just talk about the inequality you had on your own. How did you know what kind of curve or line to draw? Some of you have dotted lines, some of you have solid lines. If you have a strict inequality, you need a dashed line. If you have equality with your inequality, then it is a solid line. So your circles should have been dotted circles. Really, everybody except Blue, your team leader, should have had dotted lines. Blue, y equals 2x minus 3 was the only solid line. Okay? Now, then you shade it. Okay? Anytime you have an inequality, you shade where you have solutions. Okay? Most of you were picking a point and determining if that was a solution or not. What's the easiest point to pick? 0, 0. If 0, 0 is not on your function, then you can pick it. If your graph goes to the origin, you have to pick a different point. Okay, maybe 1, 1 or 2, 2 or something. I don't know. Okay? Now, when you combined the two inequalities together, where did you shade? Where both shadings overlapped. Okay? If you took 3 of those and put them together, where is the shading going to be? Where all 3. Okay? What does the shading represent? All the solutions that satisfy, in your case, both inequalities. Okay? When you shade, that represents how many solutions? And how many are there? Infinitely many. Very good. Okay. So, when we shade, anytime you have a corner that is bounding the shading, we call that a vertex. Okay, see where these lines are intersecting and the shading is inside? That is a vertex. This up here, not a vertex because it's not bounding the shading. Okay? This is a bounded solution because it's bounded everywhere. Okay? It doesn't go on and on in any direction. Okay? Okay, so there's 3 different kinds of solutions that we can get. We can get a picture that looks like this, which is bounded. We can get a picture like this. This yellow is going to keep going and going and going inside of the parabola. This is unbounded. Okay, and then this is no solution. This line is shaded this way. This line shaded the opposite way. These lines are parallel. They never intersect. So their shadings are never going to intersect. Okay, so that is possible. Okay, how many vertex points does this picture B have? It has 2 vertex points, one right here and one right here. How do you think we find those? You have to find where 2 equations are equal. And when did you...
of equations.
Yes, you're going to have to solve a system of equations if it's not obvious by the graph.
So a vertex doesn't have to be a bound. It can be an unbounded solution as well. It doesn't have to be only bounded.
Right, but it's bounding that part of the solution. Does that make sense?
Yeah.
Okay. So we are going to do 2 examples. Here is the first. You will be graphing a few circles today, just FYI. X squared plus y squared is less than or equal to 25. When you graph these, the first thing I would do is just look at the equation. X squared plus y squared equals 25. What does that look like? It's a circle with a radius of 5, and it's solid because
it's got the equal to. So how do you know when the circle's center is not?
There will be like an x minus 1 the quantity squared. Right one. Yeah. Yes, you take the square root. Okay, let's recall geometry really quick. A circle, x minus h squared plus y minus k squared equals r squared, where the center is at hk. That's something that you learned in geometry, something we talked about last year when we were preparing for the NISA. Okay. So now, where would I shade my circle, inside or outside? If I pick 0, 0, does it satisfy?
Yes.
Yes. Okay. So what I'm going to do, I'm going to color it in with blue. All right. Now, you don't have to, but if you do shade very, very lightly. Okay. Now, I'm going to use green for my next one. 4x minus 3y. I'm going to graph the line equals 0. Okay. How do you want me to go about graphing this? Solve for y?
Yeah.
So negative 3y equals 4x, which means y equals negative 4/3 x. Wait, oh, positive. Okay. What's our y-intercept? 0, and we have a slope of?
4/3.
Oh, it is dashed.
Katie.
Thanks, Katie. And what side? Where do I shade? We can't pick 0, 0.
Can't pick 1, 1.
How about 1, 0?
Yeah, I like that.
Does 1, 0 satisfy this?
4, no. 4 minus 0 is 4. It's not less than 6.
So we shade away from that,
Yep.
which means my intersection is in here.
Yes.
Now I did a horrible job of drawing a perfect circle. So these vertex points, okay, we're going to need to find.
Oh.
I need to know where 4x minus 3y equals 0 and x squared plus y squared equals 25 share a common point. Okay? Can we use substitution? We already know y equals this, don't we? Okay. So can we say x squared plus y squared equals 25? Which means x squared plus 16/9 x squared equals 25. What's x squared plus 16/9 x squared? Which means x squared is what? 9? X is what? Plus or minus 3. When we're a positive 3, what's x? What's y? When we're a negative 3?
Negative.
3, 4. Negative 3, negative 4. Those are our two vertices.
That's pretty cool.
When you take 25 divided by 25 ninths, multiply by the reciprocal, and we're left with 9. Okay. Tomorrow we're going to be working with linear programming, so it's essential that we can set up a word problem with system of inequality?
A lot of words.
Yeah, we can do it tomorrow.
Okay. So, a liquid portion of a diet is to provide 300 calories, 36 units of vitamin A, and 90 units of vitamin C. A cup of drink X provides 60, 12, and 10. A cup of drink Y provides 60, 6, and 30. Set up a system of inequalities that describes how many cups of each drink should be consumed each day to meet or exceed the minimum daily requirements. What does X stand for? Or what do you want X to stand for? Amount of drink X. And then Y is going to be our amount of drink Y. Now, how many calories do we need? We need at least 300. How many are in drink X?
60.
Okay. How many in drink Y?
60.
And that needs to meet or exceed 300. How much vitamin A do we need? We need 36. In drink X, there is
12.
in drink Y. And so that needs to meet or exceed 36. And then we have vitamin C. How much in drink X?
90.
How much in drink Y? And we need how much? We need to meet or exceed 90 units. Now, when we're talking about word problems, can the amount that I drink be negative? No. So we need to say that X and Y are greater than or equal to 0. Because we cannot consume a negative amount.
Just working in the first quadrant.
Very good. Since X and Y are both greater than or equal to 0, we are working in the first quadrant. Okay? So we can do this.
So A wrong.
Now, we need to graph these. 60x plus 60y equals 300. We don't have to put these in slope-intercept form every time. What can we do? Okay, we can say, all right, what's our y-intercept? What's our x-intercept? And where would we shade? Towards or away from 0, 0? If I plug 0 in for x, y is 5. Away, okay. How about this one? What's our y-intercept for our second equation?
6.
X-intercept?
3. Away.
And we would shade away from 0, 0. And then in our third equation, our x-intercept
9.
and our y-intercept.
3. Away.
So we have to shade away from all of these, correct?
Yes.
We have 1, because this is going this way, right? 2, 3, 4 vertex points. Ooh. What's this one? Ooh, that one's easy.
Oh. 6 0.
What's this one?
6 0.
What?
6 0. 0 6.
0, 6.
Yeah. Geometry.
All right. This is where the blue and the red line intersect. I guess I should say this was blue, this was green, and this was red. Right. Okay. So this is where our blue line, 60x plus 60y equals 300, and 10x plus 30y equals 90 intersect. Okay? If you think that it is 3, 2, that is excellent, but you can't just guess 3, 2. What do you have to do if you want to make sure it's 3, 2?
Systems of equations.
Okay, well, if you think it's 3, 2, plug 3, 2 in for this one and make sure that it's true. Okay, if you can't tell what it is, you need to solve the system of equations.
It was.
Okay, so for this one, I would multiply this by -2.
Yeah.
So then I could cancel out my y's.
Yes.
So 60 plus -20x would be 40x.
3, 2 just.
Our y's would go away. 300 plus a -180 is what? So x is 3. Okay. For this vertex point, we're talking about where the blue and the green intersect. So we're talking about the system of 60x plus 60y equals 300, and 12x plus 6y equals 36. Okay? How would you want to solve this system?
Multiply by 10,
Multiply this guy by,
5, -5, 10.
you can use substitution. Let's do, I like 10 because it's a nice number to multiply. Let's do -10. What is 60 plus -120?
-60.
60 plus -60 goes away, and 300 plus -360. So x is what? Which makes y what? What is, this is 60 plus 60y equals 300, which means y is what? 4. So there are your 4 vertex points. Okay? If you think you can tell it from the graph, you have to check. Okay? Otherwise, you're going to need to use algebra to really be sure. Okay? Like I said, this is something that you did last year, right?
Yep.
Alright.